Hey guys, so this is just this week's video of all the questions we ran through during the week. So same old story. If any I forgot, let me know, and any you want me to do, just send them on. But yeah, let's jump straight in. So question one says Alex gets injections of a medicinal drug. Each injection has 15 milligrams of the drug, and each day the amount of drug left in Alex's body decreases by 40%. So if we decrease something by 40%, that's the same as getting like 60% of it. So that's the same as multiplying by 0.6. Okay, so the amount of drug left in Alex's body T days after a single injection is given by this formula here. Find the amount of drug left in Alex's body 2.5 days after a single 15 milligram injection. Okay, so 2.5 days, that just means we have to sub in 2.5. So you can think of this like a function. If we call this d of t, this means the amount of drug left in Alex's body based on time. There we go, time. So there we go. If you can think of it as like our output. So d of t is going to be, actually I'll keep, before I even do it, let's just hammer this home. So think of a function like this. So obviously our function looks something like this, and it decreases by 60% each time. So this is 15, and we're decreasing and decreasing and decreasing. Um, and so this is our time across here. So as we go further up in time, so at the very start at time equals 0, we have 15. And then as we say 1 day in, we go up and we get an output. So this is our d of 1. And then if we go to 2, this is our d of 2, and so on like that. So that's just what's going on visually, just to kind of hammer home the point. But let's keep going. So we want to find d of 2.5, and that's going to be 15 times 0.6 part 2.5, which if we put in our calculator, that is going to be 4.182822014. Okay, it says correct 2 decimal places, that's 4.18 days. Perfect. Okay, so how long after a single 15 milligram injection will there be exactly 1 milligram left in Alex's body? So let's think about our thing again. So this was our equation. We started at 15 and we kind of decreased by 60% each time. So at t equals 0, you can see we're at 15. At t equals to 1, we're at some kind of a number. At t equals 2, we're at some kind of a number. And they're telling us the number we want is 1 milligram, so all the way down here. So how far out do we have to go so that we intersect our line? And then this will tell us how many days. Let's call it x days. So this means after x days, we get 1 milligram of drug. So it's kind of the opposite question we were doing before. Before we said we went to 2.5 days, and we went up and we got 4 point something days, 7 say. Now we know, or 4.18 milligrams. There we go. So we got 4.8 milligrams, and now they've given us a milligram, and we got to work backwards to find the days. So if you think back to the question we were doing about phone sales, if you remember that, we found the inverse function of the phone sales. So if this is our function for milligrams left in the body, so on this side we have milligrams, and on this side we have time. Now we want to swap that around so that we find the time from the milligrams. And so let's do that. So let's divide by 15, say. So d of t divided by 15 is equal to 0.6 to the power of t. Then what we can do is take the natural log of both sides equals natural log 0.6t. Do you remember the log of anything to the power is actually the same as the power multiplied by the log. And so what that means is we can actually then divide by, so this is inside the brackets, and this is all going to be divided by 0.6 here. Okay, and so that's equal to t. And so now we've kind of swapped it around. So instead of subbing in t and getting milligrams, now we're going to sub in milligrams and get t. And so usually when we're talking about functions, what we sub in is some kind of a value. So let's call this x. and then we get back some kind of an output. So let's call this d of t. But now, just to kind of distinguish between this and this, we're going to put a little -1 at the top. And that just means it's the opposite function of d. And now we can kind of answer the question. It says, if we input 1 milligram of drugs, what time will we get back? So we're going to put in 1 milligram of drug here, and we should get the time here. And if we put all this into our calculator, we should hopefully get out in 1 over 15 out in 0.6. So this is 5.301 blah blah blah. So this is 5.3 days. Correct to 1 decimal place. Perfect. So this here is the inverse function of our function up here. It does just the exact opposite of it. And so, yeah, perfect. Okay. So next question says, Alex is given a 15 milligram injection of the drug at the same time every day for a long period of time. Explain why the total amount of drug in milligrams in Alex's body immediately after the 4th injection is given by this formula here. Well, let's think about it. So he's just got the injection just there, and so the drug has no time to have decreased in his body. It hasn't spent a day in his body to decrease by 40%. So straight away we know he definitely has, let's forget about this for a minute. He definitely has 15 milligrams in his body. We know that for certain because we just injected him. But what he also has is all the drug in his body from the injection the previous day. So this injection, this is day 4, say. So on day 3, he also had an injection, and now this drug has had a day to decrease. So it's 15, 0.6. So it's had a day, it's had a chance to decrease by 40%. But also we have the drug that he got on day 2, and this has had 2 days to decrease. So this is 15, 0.6 squared. Or you can think of it like 0.6 times 0.6, which is the same thing. And then finally, day 1 had 1, 2, 3 days. Had 1, 2, 3 days. And so that's 15, 0.6 to the power 3. Now you can see that this is exactly what they wanted. So it does say explain, so we would need to give some kind of words. So all you would need to say is that the first 15 represents the injection he just got, and then the next 15, 0.6, represents the shot from the day before, and then the day before, and the day before. And that's all you have to say. Perfect. Okay, so now we want to find the total amount of drug in Alex's body immediately after the 10th injection. Okay, let's think about it. So he's just had his 10th injection. Let's call this day 10. That's 15. He also has the drug from day 9, so that's 15, 0.6. Then he also has day 8. 15, 0.6 squared. Day 7, 15, 0.6 cubed, and so on, all the way up to 15, 0.6 to the power of 9. So this is day 1, so it's had 1, 2, 3, 4, 5, 6, 7, 8, 9 days to mature. Perfect. So we could add all these up in your calculator and we should get the right answer. But in your log tables, there actually is a formula for that, and that's going to be S9 is equal to... So it's the exact same thing. We could do this in our calculator, and this is the way I want you to think about what's happening in the background. But because it just takes so much time, mathematicians have just worked out a way to kind of reduce this all down into a formula, and that is going to be a times 1 minus r to the power of n over 1 minus r. And so what this is a is just our first term, or is what we multiply by each time, so that's 0.6, 0.6, 0.6. And n is the sum we want. So if we want to add the first 2 days, that'd be s. Oops, I wrote it up here. This would be s2. If we wanted to add the first 3 days, that'd be s3. Same for 4 days, that'd be s4, and so on and so on. So we want the first 10 days. So all the way up to here, s10. So that means we're going to get s10 is equal to a is our first term, 15. 1 minus or is 0.6. Our n was 10, and 1 minus 0.6. And whatever that happens to be in your calculator. So 15 times 1 minus 0.6 to the power of 10 over 1 minus 0.6. And that should be 37.27. And it's to two decimal places, so that's 37.27. I rounded it already. There was a bunch of stuff here. And that's going to be milligrams because we're measuring the amount of drug left in his body. Or the total amount of drug, sorry. Perfect. Okay. So now we want to use the formula for the sum to infinity. Okay, don't get caught up in the language, okay? Don't worry about all this. Just think about after a long period of time during which he gets daily injections. So on his first day, he's so it's the same as all this. So we can kind of repeat what we were doing up here. This was how much drug was left after 10 days, the stuff we had up here, all the way up to 15, 0.6 to the power of 9. But what if we wanted more than that? We wanted to keep going. So we had 15. Now we had it 11 days, then 12 days, and then so on and so on. And we went all the way up forever for the rest of the time. How much drug would be in Alex's body? And so let's think about it. Let's use our formula. So our n here is, this was S10, this was S11, this would be S12, this would be S, well, it has no n, so it's just S infinity. So let's rewrite Sn is going to be our first term, 1 minus or to the power of n over 1 minus or. That means S infinity is going to be, our first term is 15, 1 minus our or was 0.6, power of infinity, and 1 minus 0.6. Okay, so 0.6, another way of writing that is 3/5. And if we do that to the power of infinity, you can see that this is going to get smaller and smaller and smaller. Do you remember if this was 0 and this was 1? If we have 3/5 and then we multiply it by 3/5 again, and then by 3/5 again, so this would be 3/5 squared, cubed, 3/5, 4. We get closer and closer and closer and closer to 0. So eventually in here would be 3/5 to the power of infinity, and that we just call that 0. So this is 0. That means up here, all this would go to 0. We just get 15 times 1 over 1 minus 0.6. So we just put that in our calculator. 15 over 0.6, and that is 25. Okay. One thing to note is that you can see this won't work because our or was 3/5, so it was a fraction and it was less than 1. So that means that when we multiply it by itself, it would get smaller. If our fraction was up here, say it was 6/5, if we multiplied it by itself, it would actually get bigger. Up here, 6/5 squared, 6/5 cubed, and this is the same for any number greater than 1. It would get bigger, but any number less than 1 would get smaller, because you can see that 1 times 1 is obviously itself, so this is kind of like the turning point. This is where everything changes. And so that means if what we're multiplying by each time isn't smaller than 1, then this here won't work. But you can see that's kind of obvious from what we're actually doing in the background. If we multiply each time by our thing, we're actually going to get bigger and bigger and bigger. And if we multiply each time by something smaller, we'll converge on some kind of a number. Okay, but yeah, on to the next question. So this was milligrams. Okay, so next part says, Jessica also gets daily injections of a medicinal drug at the same time every day. She gets D milligrams of the drug in each injection, where D is just a number. Each day the amount of drug left in Jessica's body decreases by 15%. Okay, so in Alex's case, we knew it was 15, but now we just know it's D. In Alex's case, it was 40%, but now it's 15%. And getting 15% is the same as multiplying by 85%. So yeah, let's think about it. So use the sum of geometric. Blah, 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 blah. Okay, don't worry about all the jargon. Let's just think. Same thing we were doing for Alex. If on a certain day, say day 10, she gets an injection. She gets an injection of D. Then say she also has the injection from the day before. So it's D times 0.85 because this is 85%. Remember, it decreases by 15%, so it's the same as multiplying by 85%. And then she has D 0.85 squared, and then she has D 0.85 cubed, and so on and so on and so on. Okay, and so now we just have to turn it into this. So we know if we want to calculate any s, so this would be s2, this would be s3, s4. If we wanted to calculate any s, that's Sn a 1 minus or to the power of n 1 minus or. A here is just our first term, d. Or here is our 85%, so that's 0.85. N is still n, and or is 0.85. And so now we just have to use the sum of the geometric series to show that the total amount of drug ingested goes immediately after. Okay, so if we put into our calculator 1 minus 0.5, that's going to be 1 minus 0.85 to the power of n over. So on the bottom here, 1 minus 0.85 is the same thing as 3/20ths. And we know if we divide by a fraction, that's the same as multiplying by the opposite of the fraction. And so that is just going to be 20d 1 minus 0.85 to the power of n over 3, which is exactly what they wanted. And so that's all we have to do. We just have to show that this, oops, I've separated everything. We just want to show that Sn, so the sum, so that's the sum, the s's, is equal to this. And that's what we did. Okay, great. And so final question says, immediately after the 7th injection, there are 50 milligrams of drug in Jessica's body. Find the amount of drug in one of her injections. Okay, well, we just figured out a formula for the sum, the amount of drug left in her body, and that's 20d 1 minus 0.85 per n over 3. Now we're told that after the 7th injection, so S7, she's going to have 50 milligrams left in her body. So 0.85 to the power of 7 over 3, and this is equal to 50, and now we just got to find d. So if we multiply across by 3 and then divide by 20 at the same time, we'll get d is equal to 1 minus 0.85 power of 7, 50 times 3 over 20. Now if we divide by this term here, that means d is equal to 50 times 3 over 20 times 1 minus 0.85 to the power of 7, and this is equal to 50 times 3 over 2 times 1 minus 0.85 to the power of 7, and that is 110.3877 nearest milligram, so that's 110 milligrams. Perfect. So that's the whole question done. I know questions in sequence series are long, because they're kind of a separate topic. They usually have a whole question to them, but you can see that this is a full question. Like, this is 50 marks, and if you guys can definitely do that in your test, and you'll just bag 50 marks straight away. But yeah, that's the full question, and we'll move on to the next question. Okay, so before we go into the next question, I just want to give you a little bit of information that I forgot to mention earlier, but I did mention it in the grind, but just for the context of this question before we do it again, I want to remind you of something. So if we have like the sequence that we were doing before, but instead of a series, so a series was adding them each time, and we had something like this, 0.6 squared. Now, instead of a series, if we just listed them as a sequence, then they would look something like this, 15, 0.6 cubed, and so on and so on. Okay, but if obviously here we're multiplying by 0.6 each time, and it's kind of obvious like that, but if it wasn't so obvious, and we wanted a way to figure that out, how would we do that? Well, one thing we can do, and we can see, is that if we take this term here and divide it by this term, we'll get 15, 0.6 over 15, and the 15s will cancel, and we'll get 0.6. And now if we take this term and divide it by this term, 15, 0.6 cubed over 15, 0.6 squared. The 15s will cancel, 2 of these 6s will cancel that, and we get 0.6. So you can see that if you divide any two consecutive terms, they should equal this exact same thing. And why this is useful is, it won't come up in this question, but another thing I should just mention is, if this was, instead of 0.6, it was d, like this, and we want to figure out what d was, basically. one thing we could do is say that this would be D and this would be D. That would mean the 15s would cancel, this would be D. One thing we can do is find the ratio that we're multiplying by. So take this term divided by this term, we'll get D. And take this term divided by this term, we'll also get D. But if we know that these are equal to each other as well. So, okay, it won't come up in this question, and it's kind of hard to explain, but we can basically figure out things about D that we wouldn't otherwise be able to figure out. But anyway, enough about that. I kind of went off on a tangent there. What I really want to talk about is, so this was a geometric sequence where we multiply by something each time. If we, I'll write that there, geometric. If we wanted to talk about an arithmetic sequence, that would be a sequence where we add something each time. So that'd be 15 plus D, 15 plus 2D. Or I'll even write it like this, D plus D. This would be 15 plus 3D, and so on. And now if we wanted to find what we're adding here each time, instead of dividing, we just have to take away. So we take this term, take away this term, the 15 will minus the 15, and we get D. We take this term, 15 plus 3D minus 15 plus 2D, 15 with the 15, two of those with one of those, we get D. Okay, so to find the ratio of a geometric, you divide, and to find the difference of an arithmetic, you add. Okay, but anyway, why is that useful? Well, here we see. So this says the first term in arithmetic sequence is A, the common difference is D, so that means the next term is A plus D, A plus 2D, and so on. The 18th series, so this is term 18, say this is 1, 2, 3, this is term 18, is 25, and the 21st term is 32.5. Okay, use this information to write down two equations of A and D. Oh yeah, this is exactly the question I was talking about, sorry. So you saw before, if it was just D, we can use the fact that these two ratios are the exact same. So if we divide this one by this one, it should give us the exact same answer as if we divide this one and this one. And the same for this. If we take away this from this, it's the same as this from this. And we can use that to figure out A and D. Okay, perfect. So let's do that. Well, first we need an equation for term 18 in terms of A and D. And how are we going to do that? Well, you see the 1 goes with the 0D here. The 2 goes with the 1D. The 3 goes with the 2D, sorry. The 18, therefore, goes with the 17D. And the 20 goes with the 20D. So the 21 goes with the 20D. And therefore, our two equations are just this. If 25 is equal to the 18th term and the 18th term is also equal to A plus 7D, then 25 is equal to A plus 17D. And same for our second equation, 32.5 is equal to A plus 20D. Perfect. So we've done that. We write two equations of terms in D, and now we need to show that D is 2.5 and A is, and find the value of A. And you can see here, this is just simultaneous equations. So what are we going to cancel? Well, let's cancel the A's because they're already done for us. So let's just multiply everything by minus, and then add the two equations together. Oops. If it wants to work with me, there we go. So these two will cancel. 32.5 minus 25 is equal to 7.8 is equal to 3D. 7.8 divided by 3 is, maybe I got that wrong. 32.5 divided by, or minus 25, 7.5, sorry. 7.5, then we divide by 3. There you go, that will give us the 2.5 is equal to D. Now we need to find the value of A, so we can just sub back into any equation. 32.5 is equal to A plus 20 times 2.5. So just a little bit of algebra, bring this over to that side. 32.5 minus 20 times 2.5 is going to be minus 17.5. Perfect. Now it says use the sum of the first n terms of the series. It tells us the sum of the first n terms of the series is 2,750. Find the value of n. So it means A plus D plus A plus 2D plus blah 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 n times, so a plus n minus 1d, and all of this added together should be 2750. Same thing, there's an equation for same thing that we had for the geometric series. We can call this Sn, and there's an equation for Sn, and it should be n divided by 2 times a plus n minus 1 times d. But this should be in your log tables anyway. So now we just need to find, we know that this is equal to this, so this is equal to 2750, and we need to find the value of n. So n divided by 2, a here we knew was 17.5, plus n minus 1 times 2.5. And now we need just to work backwards and find n. So we can multiply by 2, so 2 multiply across by 2 is equal to n times, what actually we can do is multiply n by the n as well, so that'd be minus 17.5 n plus n times n minus 1. Oops. We can multiply in this 2.5, so 2.5 n minus 2.5. And now we just need to keep going. I'll clear a bit of space. Hopefully I'm not making any calculation errors, but if I do, don't focus too heavily on them. Just think about what we're actually doing. So we set this equal to this, and we just get to work backwards then and find n. I'm not too worried about calculation errors. Okay, so let's keep going. So 17.5 n plus 2.5 n squared, I'll just multiply in this n, minus 2.5 n, and all of that's equal to 2 times 2750. So that means 2750 is equal to minus 17.5 n minus 2.5 n. So that's going to be, I think, minus 20 n. Let me just check because I don't want to make a mistake. Yep, minus 20 n plus 2.5 n squared. Now if we multiply everything by 2.5, 2 times 2.5 times 2750 is equal to minus 20 times 2.5, or we should divide by 2.5, sorry. 2.5 plus n squared. And now that should be n, and now we'll just put everything in our calculator. So 2 over 2.5 times 2750, that's going to be 2200 is equal to minus 20 divided by 2.5 minus 8n plus n squared. Probably handiest would be the minus b formula. Well, first let's bring this across. So 0 is equal to n squared minus 8n minus 2200. N is going to be minus 8 plus or minus the square root of 8 squared minus 4 times 1 times minus 2200 all over 2 times 1. So we could put this in our calculator, and n should give us 8 plus square root 64 minus 4 times 2200 over... Oh, I must have made a mistake because I'm going to get a square root of a minus number. Just hold on, let me check back where I remember. So the final quadratic you should get is n squared minus 15n minus 2200. So that's just calculation I made earlier, but that's okay. So now this is 0. Yep, so n is going to be minus 15 plus or minus the square root of 15 squared minus 4 times 2200 all over 2. Put this in your calculator. This should be 15 squared. Still giving me a problem. Let me show you behind the scenes. So this is what you should get. N squared minus 15n minus 2200. So our n is going to be 55 or minus 40. N is equal to 55 or n is equal to minus 40. Don't worry about the calculations. Doesn't matter too much. What I really want to get to is that if we think about what n was, this was the number term. So if you go all the way up here, this was term 1, this was term 2, this was term 3, blah, blah, blah. This here was term n. And so you can see that n is always going to be greater than 0. You can't have a negative term because the sequence starts here. You can't have something in the sequence that is before the sequence, if that makes sense. And you also can't have n as, say, a half, because there's no terms between terms. And so that means n has to be positive and it has to be a whole number. And so that's why down here we can reject this value for n, because n, you can say, is a natural number. You don't have to say that, you can just say reject, but you guys know natural numbers are just any whole positive number. Perfect. So that's the first part of the question. Second part says, geometric sequence is as follows, find or the common ratio between the terms. Okay, so remember I said before, if you're finding the difference in the terms, we take this one and minus this one. If we're trying to find the ratio, we're going to take this one and divide it by this one. So this means ln x squared over ln x. If we're squaring any log, that's going to be the same as multiplying by that power over ln x. And that means our two logs will cancel and we get 2 is equal to our ratio. Perfect, so that's the common ratio. Just to make sure, we could also check these ones. So ln x to the power 4, ln x to the power of 8. That's the same as bringing these down here. So 4 ln x, 8 ln x. Sorry, should we do the other way around? 8 up here and 4 down here. So always take the second one and divide by the first one. So that means 8 goes here and 4 goes here. These will cancel. This gives 2, and that means we get the same answer as 2. Perfect. So that was us just checking our work. Okay. So now it says if t8 minus t6 is 45, find the value of 6. What t refers to here is what we were just referring to as n back here. So this is 1, 2, 3, 4. This is just like term 1, term 2, term 3, term 4, blah, 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 all the way up to term 8. And in here somewhere is term 6. Perfect. So this is saying that t8 minus t6 is 45. And how are we going to find the value of x? Well, over here there's no x seen anywhere. So basically we're going to have to find two equations for t8 and t6 in terms of x, set it equal to 45, and then work backwards and find x. So how are we going to turn t8 and t6 into values of x? Well, what we can do is actually, let's write out our sequence. So this is ln x, this was ln x squared, this was ln x to the power of 4, ln x to the power of 8. You see that if we bring down our power for each one, ln x, 4 ln x, 8 ln x, and now if we rewrite this as 2 ln x, 2 squared ln x, 2 cubed ln x, and this would make sense because this goes back to what we were multiplying by just now. You see here, we multiply by 2, multiply by 2, multiply by 2. X1 is obviously going to be multiplied by 2 again, so 2 to the power of 4 ln x. And we can, it's close to t8 and t6 anyway, so we can just keep going, or we can figure out a pattern for them. So here you see the 1 goes with the 1, 2 goes with the, you can actually think of this as 2 to the power of 0. So 1 goes with the 0, 2 goes with the 1, 3 goes with the 2, 4 goes with the 3. So that means Tn is going to be 2 to the power of n minus 1 ln x. And so if we wanted T8, that would be 2 to the power of 8 minus 1 ln x, which is 2 to the power of 7 ln x. Perfect. And if we, drop my pen. If we wanted T6, that would be 2 to the power of 6 minus 1 ln x, so 2 to the power of 5 ln x. Perfect. And now it says T8 minus T6 is 45. But we just found out that T8 was 2 to the power of 7 ln x, and T6 was 2 to the power of 5 ln x equals 45. And now we just have to work backwards, so we can actually take out this ln x and multiply by these. So you can imagine if we multiply ln x by 2 to the power of 7, we get this, and ln x by minus 2 to the power of 5, we get that. Perfect. And now what we can do is say ln x is, you can divide across by this term, 45 over 2 to the power 7 minus 2 to the power 5. Then if we wanted to get rid of the ln's, the opposite of ln is raising something to the power of the same base. So the opposite of a log is raising something to a power. And that's what we're going to do here. So the opposite of ln is e to the power of, e to the power of. These two would cancel. Cancel, and we'll get x is equal to e to the power of 45 over 2 to the power 7 minus 2 to the power 5, whatever that happens to be. So let's do that. E, wherever it's hiding on my calculator. There it is, e to the power of 45 over 2 to the power 7 minus 2 to the power 5. And this is 1.59799. So that's 1.6. Or one decimal place, so that's, 1.6. Perfect. So yeah, that's the whole question done there. This again was, I think, a full question. I didn't include how much marks it was, but you can see that they're full questions, so you can get loads of marks for them. They're a great one to do, and they're not too complicated. And yeah, next week we'll be continuing on with them. So good luck with that, and I'll see you guys then.